Good morning. My name is Omar Valles, and I'm going to talk about my evidence of physics. In this video, I'm going to talk about the series circuits and a parallel circuit. So I'm going to explain first how the series circuit works. As you can see, I have a battery, a switch, some cables, and a light bulb. Well, 3 light bulbs. So when you connect the switch, you can see that all the light bulbs lit up, and when you power off the switch, they turn off. But when you disconnect one of the bulbs like this, all the bulbs just turn off, and you reconnect it and every bulb turns up. So we have the resistance here, the voltage, and with the current we can see that we have a 0.55 amperes. Now I'm going to talk about the other circuit, that it's a parallel circuit. So we have the 24 volts, the resistance, light bulbs, cables, and a switch. So we turn on the switch, every light bulb turns up. When you disconnect one of the bulbs, just this one disconnects. That's the difference between the series and the parallel, among other different things. This is the most important thing that difference one of each other. You reconnect it, and you can disconnect whatever light bulb you want to disconnect. Just the one that you disconnect is going to turn off. As you can see, I can disconnect these two, and this one will still be lit. So now we have a little table here. As you can see, there is the circuit and the parallel. The voltage is the same as the battery. We have the current and the resistance. So the voltage is the same as the battery that it has. The current, you can use the current ohmmeter that we have here, or you can have it by doing voltage times the divided with the resistance, and the resistance is going to be the sum of all the resistance in the circuit. But in the difference in the series and the parallel circuit is calculated differently. So in the series circuit, you have to sum the 3 resistance, or the number of resistance that you have, and in the parallel circuit you have to do it like this. So we have 14 plus 14.5 plus 14.5 plus 14.5, we have 43.5 ohms of equivalent resistance, and we do 43.5 between 24, and we get that 55 amperes. And for the parallel, we use 24 voltage, and we have this resistance, we divide it, and we have our current. Or easily with this one, we can simply grab the amperometer here, and we can see that it has the same thing. So also we have a little questions for this practice. How do Christmas lights work? Well, above other things, I think it's a parallel circuit because they lit on and lit off depending in the order that they do, but they never get all turned off. So that's why I think it's a parallel circuit. Then if some resistors are working on a circuit and the others are disconnected, we are talking about a parallel circuit, because like we can see in this one, if I disconnect one resistors, all are going to still lit up except of the one that turned off. And how the value of the equivalent resistance of a parallel circuit with respect of any resistance. So the difference is that here we divide by the same amount of resistance on each resistor, and that's the important thing in a parallel. And to finish, we have, if the voltage drop on a circuit, it's the same in each resistor that conform it. How the resistors are connected? They are connected in series, as we can see in the other in the other circuit that they are in the same voltage, same order, and they work all the same. Well, thank you, and that's all.